Hi, I'm James Harmison. I'm going to talk to you a little bit today about DevSecOps for the DoD. It's going to be just a short history lesson to give you some context into what DevSecOps means. And I'm going to kind of provide a case for the future of software development and delivery in the Department of Defense. So first off, a little bit about myself. I'm a lifelong nerd. I've conducted cybersecurity for the Department of Defense starting in 2016, first as an incident responder and threat hunter, in defensive cyber operations, not doing like ISSO duties. I was a dev hobbyist for a long time and was provided the opportunity to become an infrastructure engineer for the Department of Defense, specifically in the Networking Engineering Research and Development Office in the Cyber Protection Brigade. I'm not really much of a history buff myself. As you can guess, I like books, but I really like computers more. But I am good at Googling interesting things, and I know how the Wayback Machine works, and I wanted to share where I kind of think all of this confluence of ideas has come from, because I think understanding that history gives us context into the decisions that were made that got us to where we are today. Because DevSecOps is not just a way of developing and delivering software, it's a way of accomplishing operational goals with software. Software is not written in a vacuum, it's built for a purpose. And so I wanted to understand more about whether DevSecOps was a good way, or if it was better than the old way, or why people started talking about it as much as they have. What does it mean? How is it any different than those things that came before? And if this is a thing that the DoD could do, how would they do it? Should they do it? There's a lot of slides. I'm going to share a link at the end of this video that includes a link to the slides. Some of them will go pretty fast, though. Some of them are very short diagrams. So I think you'll enjoy our talk today. I hope to keep it interesting. First, lots of people try to define DevOps or DevSecOps in terms of what it's not. They try to vilify those things that came before, and the waterfall model is often what's most heavily criticized. The waterfall development model is usually illustrated in some way like this. The number of steps vary and the descriptions of those steps vary, but the point of the waterfall development model is that early steps are independent of later steps and they're conducted serially. You start by defining requirements, you move towards analysis, design, implementation, later testing, and then operations, which often includes some kind of long tail maintenance effort. This is probably what you think of when you think of waterfall development. It's often credited to Dr. Winston Royce, who identified these 7 phases in a 1970 paper on managing large software engineering projects. The paper was from IEEE WestCon, and it was titled Managing the Development of Large Software Systems. He didn't call it the waterfall model in that paper. He just observed these phases, and really he criticized this model. I'm not sure why it's so often credited to him, but he didn't really say that this was the way things should be done. He said it was risky and invites failure. He pointed out that there was a major redesign that was likely to be required because there was no good feedback loop anywhere in this process. MIT and the Navy actually implemented the first waterfall design. In 1956, they were building bespoke software for bespoke computers using bespoke machine language just for those computers. Their linear design focused on requirements definition first, and then planning, implementation, and testing. They emphasized that they often built the parameter tests before the code or while coding, and tests were always against the specifications, not the code itself. Individual modules weren't considered done until they passed those parameter tests. And that sounds a lot like test-driven development to me, which is really interesting to see that test-driven development was being advocated for in 1956. But they did have a very rigid requirements and planning and design over to coding and testing barrier. So it was linear and phased, but from there, I think they went about it pretty smartly. And to be honest, they were kind of figuring out how to do projects like this because software systems didn't really exist in this way much earlier than 1956. So Winston Royce's thoughts overall on what software development for large projects should look like is that he often said that you really needed to design, define, and allocate the data processing modes, even at the risk of being wrong. He was a heavy believer in strong design before any implementation had been done, going down to a really finite level and a lot of detail. He then thought that documentation of that design was really, really important. He said, the first rule of managing software development is ruthless enforcement of documentation requirements. And his justification for that was that an acceptable written description forces the designer to take an unequivocal position and provide tangible evidence of completion. If the documentation does not yet exist, there is as yet no design, only people thinking and talking about the design, which is of some value, but not much. He also said that the real monetary value of good documentation begins downstream in the development process during the testing phase and continues through operations and redesign. So his point here was that documentation was critically important even in the design phase, before any implementation had been done, because the documentation of that design should serve as the source of truth for what things should be implemented in order to achieve. And I really like his point about it forces the designer to take that position and provide tangible evidence. He's saying that you have to have a goal, and you have to admit that that is a good goal and a worthy goal. And then you have to be able to benchmark yourself against that goal. And I don't see a lot wrong with Winston Royce's logic there. It sounds pretty sound to me in the general case. Winston Royce thought that the entire program should be designed, implemented, tested, and delivered for UAT 2 full times. He said, and I quote again, if the computer program in question is being developed for the first time, arrange matters so that the version finally delivered to the customer for operational deployment is actually the second version insofar as the critical design and operations areas are concerned. Literally said, do the whole thing intending to refactor from scratch. And I like to use a quote from Field Marshal Helmuth Karl Bernhard Graf von Moltke, and I think that you'll recognize the quote, if not the quotee. He said, no plan of operations extends with any certainty beyond the first contact with the main hostile force. The main hostile force here being your tests and your users. Winston Royce thought that you should account for a complete dry run in absolutely everything that you did. And that, in an era where you were delivering software into production and then it was gone and that was it was off and running for years, he thought that you should always have sort of a second pass to think through that design. He also thought that planning, control, and monitoring of the testing was incredibly important, with a testing phase being dedicated entirely to sort of an integration and user acceptance testing in modern parlance. He said, without question, the biggest user of project resources, whether it be manpower, computer time, or management judgment, is the test phase. In his time, test engineers were often not architects or developers, and they relied on the documentation that had been written earlier in order to understand what the program was supposed to do and how to make it do those things. So as a result, the testing process ate up a bunch of time, and it ate up a bunch of cycles, and it required a lot of control, and he believed that it was important to maintain a high level of control over those testing environments. Involve the customer, and this is the most forward-thinking part of Winston Royce's 1970 paper, in my view. He said, to give the contractor free rein between requirement definition and operation is inviting trouble. So he didn't even think these steps should be linear at all. He thought that customer involvement beyond requirements generation was important, both in a review of the preliminary design as well as repeated reviews of the final design in your second attempt. And that's all before we get to final acceptance and review after testing. You'll sometimes see this diagram referred to as Winston Royce's final design. The classical approach, later referred to as waterfall, was deeply flawed, and that was his point in 1970. In 1976, Bell and Thayer had a paper also at an IEEE conference titled Software Requirements, Are They Really a Problem?, where they actually coined that term waterfall. But in 1970, Winston Royce emphasized documentation, a blend of automated and manual testing, heavy customer involvement in the design process, and the need to iterate on the design through experimentation within the time constraints that you were under. It's not DevOps, but I don't think that anything in this diagram looks like a linear phased approach. And you have to keep in mind that this era of software delivery didn't include maintenance. Something would go to run and operate and would just be used in the way that it had been designed for years. There was no continuous delivery. You were contracted to deliver a software requirement. And given that environment, I think this was probably a very good model. It probably worked very well. I don't know, because I wasn't born in 1970, and Winston Royce was a doctor, so we'll just have to take his word for it. All that wisdom and knowledge and experience, though, pointed out the linear nature of software development would be problematic in many, many ways. And conventional wisdom in the academic and business worlds held that feedback loops were important and that iterative design was important. Automated testing was advocated for in 1970. All of these modern sounding sort of concerns and considerations. And what did the DoD learn? It can be anything you want as long as it's waterfall. They made it mandatory to follow a completely linear phased approach, like the one that had been talked about in 1956 in this military standard dated in 1985. So waterfall exists. Maybe it's not always been what you thought it was, but the DoD mandated the use of those linear phased approaches in 1985. And some other people started having different ideas about the way that development teams should be oriented, starting in the 90s. Grady Booch detailed his 2-cycle process for object-oriented design in around 1994. So talking about the Booch method usually means talking about diagrams. He did have one chapter in his book devoted to process, though, and it was a rebuttal to the waterfall style design that he'd been seeing prevalent throughout the industry. This is the foreword to that chapter, and there's just a couple of lines that I want to read directly off of this slide for you. He says, "The amateur software engineer either ignores documentation altogether or follows a process that is documentation driven, worrying more about how those paper products look to the customer than about the substance they contain." So really key to Grady Booch's position on software development and software design was that documentation was extremely important, but also sort of that documentation should be a living document, and that as your design progressed, that your documentation should evolve with it. So those diagrams that are involved in the Booch method, Booch and the work of 2 other people led to the development of UML, or the Unified Modeling Language, that you may have heard of from some kind of computer science or design classes. He had this chapter where he discussed the process that led to the creation of those diagrams, and in that chapter he said that developers should focus on their designs and their implementations more than the documentation or granular, carefully defined phases. He defined his process in 2 split sections, the macro and the micro process, where the macro process more aligned to the waterfall style that he found his management had come to expect, but he still defined the macro process as cyclical. And developers, he thought, should focus on the micro process, a tight loop of actions that focused on how software was actually developed. He kind of considered that macro process as a way to shield productive developers from the expectations and to enable them to focus on what he believed was the real work in that micro process. He covers everything pretty well in the book. He's a lot smarter than I am, so I'm just going to quote him a few times directly. He called the macro process the controlling framework for the micro process. He said, "Many elements of the macro process are simply sound software management practice and so apply equally to object-oriented as well as non-object-oriented systems." And he said that the macro process focuses on risk and architectural vision, the 2 manageable elements that have the greatest impact on schedules, quality, and completeness. He said, "For all interesting software, the macro process repeats itself after major product releases. And the basic philosophy of the macro process is that of incremental development." The microprocess, he said, was to a large extent representing the daily activities of the individual developer or a small team of developers. He said, the traditional phases of analysis and design are intentionally blurred, and the process is under opportunistic control, meaning that he thought that the person doing the work was the best one to dictate where in this microprocess cycle they were. He said that developers discover the abstractions that form the vocabulary of the problem domain. And that is, obviously very heavily driven and influenced by domain-driven design. He said that the microprocess focuses first on behavior and defers decisions about representation until as late as possible, which I think is just kind of an interesting characteristic of the act of developing software. He was very worried about what things did and worried about how he made them do it and how they showed what they did later. The data dictionary that he refers to in this chapter on process, he views it as a product that's generated very early on to identify the classes and objects that would need to make up a program. He said, as part of this step, we also update our data dictionary, including the new classes and objects that we discovered or invented in formulating the implementation of existing abstractions. And that step that he's referring to there is that specify class and object interfaces and implementation. And I think that the language there is really interesting. He was discovering objects and classes or inventing them as part of his solution. So in some cases, he felt it necessary to use OOP to invent new interfaces or new ways of attacking and organizing problems and data in that dictionary. Overall, he said, of both processes, the macro and the micro, an early form of the process described in this chapter was first documented in 1982 when he was first forming these ideas about how you should go about conducting software development. So, Grady Booch said to appease the managers, write software thoughtfully, use methods that emphasize design but are still iterative and incrementally are evolving that design as you go, as well as evolving the feature set. And that was specifically encapsulated in the cyclical nature of that macro process. And that's really just the development side of software delivery. It takes more than developers to release, sell, and support software in production, and Waterfall talked some about those interactions, but Booch left those kind of as an exercise to the reader. They weren't really part of the questions he was trying to answer in his books. So ISO, IEC, and IEEE had some ideas about the broader idea of software delivery and maintenance. And they worked on them together to, over time, sort of talk about this bigger picture of software delivery. The process tree for how they viewed systems and software engineering had development and operations as a very small part of how you would actually deliver software. The process flow that they described is intended to encapsulate each of the actions of those arms. And let's kind of break out and say what they needs done in each arm of that tree here. The primary process is the one that the entire structure exists to support. The primary process includes an operate, maintain, and develop loop with feedback included in the iterative cycles. And it's really close to the idea that DevOps has of this continuous cycle of feedback loops generating new development and new maintenance and operation, the way that these projects are coming together to be supported over the long term. But then you zoom out a little bit and it doesn't look super close to DevOps. The organizational process flow, I think that what this diagram and what this part of this document is trying to say is that the primary process is what drives those other processes. I'm not entirely sure because it costs $200 to download this paper, and if you want some light reading, you're welcome to go understand this a bit better and get back to me. Standard 12207 had this interesting thing occur over time, though. It was initially published in 1995, and the most recent release that I've seen is from 2017, and it continues to grow and grow and grow. It starts to really sort of fetishize the documentation of processes that need to happen in different phases, and focuses really heavily on this sort of prescriptive style of everything that should happen a certain way. But I said this earlier, I'll say it again. Software doesn't exist in a vacuum. It is written to be operationalized. Having an agreement about the way it should be developed and delivered is good. Having an agreement about the way that projects develop, deliver, and utilize software, and in some cases acquire software, I think that that's valuable. But having a really disconnected view of how those processes operate and not working on the holistic system isn't productive. But I don't think that fetishizing the documentation in a way that produces a 145-page standard on just the process of delivering software, I don't think that that helps to produce correct or valuable software. And I think that 12207 is just simply not enough to accurately reflect what it takes to deliver that software that is valuable. And in 2001, a line got drawn in the sand between those who were interested in fetishizing this documentation and building pages and pages and pages of process, and people who understood that correct software was the most important thing. This is where waterfall really became the boogeyman in the Agile manifesto and the Agile software movement. And basically their point was that everyone had been developing software wrong. This is the manifesto printed word for word directly from the Agile Manifesto, which you can go to agilemanifesto.org and pull it up. But the long and short of it is that prescribed processes and provided tools don't matter. People who work together can accomplish anything. Comprehensive documentation is not as important as functional software. Making clear how well it works means that it doesn't work very clearly. Contract negotiation and requirements definition is not as useful as happy customers with software that does what they need, and that detailed plans that explain how your thing should be done are a waste of time, because change is going to happen and you need to be ready to react to that change. And they viewed plans as the antithesis to agility, and viewed it as something that got in the way. The principles of agile software development lay out how they view to do this. Now keep in mind, this is 2001, and these software developers often made software to sell that other people bought to use. The internet was still kind of newish and the world was different, but they still emphasized early and continuous delivery, if not into production, then at least to a customer. I've highlighted the things that I think are particularly exciting, but I could go on about the Agile Manifesto and the principles of Agile software development all day. The meaning, as people understand it today, has kind of been lost to marketing hype. And so sometimes you see some of the members of the Snowbird 17 who authored the Agile Manifesto refer to these modern commercialized products based on agile development as dark agile or faux agile. They think that corporations have co-opted their document and managers have misunderstood it. And I think that agile development started really well to take off, and it didn't get as far as I think that it should have, because it really wasn't the whole picture. It was exclusively from that view of the software developer and didn't have answers for managers or companies around how to incorporate agile software development into their actual products. And so by being this partial answer, these other things started to fill in the gaps and caused this sort of discordance that really never got answered. So infrastructure engineers got interested in the agile world, and living in the internet-driven age, considered sort of a change request of their own to the agile process. Andrew Clay Schaefer and Patrick Dubois were both working in the field of infrastructure software. Patrick Dubois was a consultant, and Andrew Schaefer was a consultant and developer. They tried to fit infrastructure into the Agile mindset and called their product Agile Infrastructure. And they focused not just on technology, but also on thought models and principles. And kind of key to their Agile infrastructure idea was that development and operations needed to work together better with similar methods, but different responsibilities. And really to emphasize maximum communication, which harkens back to that Agile principle of individuals and interactions over tools and process. And there was some dissent amongst developers who believed that Agile was for them, and they liked keeping it for themselves, and they didn't think that infrastructure engineers needed to be involved. And there were a lot of operations folks who just didn't even see how it could fit the way that they worked and the needs that they had. But I think that Flickr probably changed everything, and a new movement was born. So we're going to talk kind of briefly about that. Something that I think was really interesting about the DevOps movement is that it wasn't a slow burn. The internet and software as a service required a new kind of organization, and some organizations started self-organizing really quickly. Patrick Dubois was a consultant, and he noticed in his work this animosity between the dev and ops shops. He found that they had problems working together, and they had these different thoughts, different priorities, and different ideas about how to solve these problems. And he thought that the Agile model had something to teach those operations crews, but he decided that the developers had to actually care about the operations concerns. Developers were focused on building new things to make the business successful, while operations was focused on keeping their production sites stable and fast to make the business successful. New things broke prod, and operations denied change requests to keep things stable, and the result was that the business was not successful due to this tension and animosity. Andrew Clay Schaefer was at Reductive Labs and working on Puppet. He worked with Patrick Dubois at AgileCon 2008, and they were the only two to show up to a conversation about Agile infrastructure after Patrick Dubois' presentation. And they kind of worked out the kinks in their thought model, and people started to come out of the woodwork to talk about their experiences because some teams had already been exploring it. Flickr was one of the first. They had 6 tools and 4 culture changes that they decided that helped them. They had to break the cycle and get them to work together to make that business successful. And John Allspaw was the Senior Vice President of Technical Operations, and Paul Hammond was their Director of Engineering. The essence of what they talked about was that the dev and ops melodrama was that big changes were hard to troubleshoot, manual processes were slow and error prone, neither knows how to troubleshoot the other's work, and that nobody was communicating to the other about their needs. They solved these problems by implementing new kinds of tools and embracing CI and CD. They changed their culture to match and encourage collaboration. Wonderful things started happening. They just started getting better. Their site went down less and less. They delivered new features faster and faster. And if you want to know what I think DevOps is, these guys were doing it in 2009. And if you've not watched their video yet, I really think that you should. This is an incredibly engaging video. It's 46 minutes and 21 seconds of people talking about how they were doing DevOps before it was cool, telling you where things went wrong, and telling you where things went right. And I really just encourage you to watch this at your own discretion because it's a much more compelling story than I can tell you. So Patrick Dubois got to organizing. As soon as people started talking about what it was that they were doing, old friends joined and they started a new conference. Andrew Clay Schaefer came to help out and moderate panels with Patrick Dubois right away. People started talking and things got moving really fast. When these ideas were executed well, they just made things better. DevOps isn't about making developers into operations guys, and it's not about making operators into developers. It's about those guys having a common framework in which to communicate like Agile, but across the aisle and across those teams. It really helped them to build empathy across their teams. Sometimes you'll hear this acronym around what it takes to implement DevOps, and you'll hear CAMS: culture, automation, measurement, and sharing. And if you can implement all four of those things, you're headed in the direction of DevOps. So 2012 is kind of a guess. It's the earliest I can find references to the word DevSecOps. It's from a presentation named Chris Boytert, and he's a Belgian, like Patrick Dubois. Don't mess with Belgians, they're going to automate circles around you. And basically he said that this just makes sense if you think about dev and ops and the way that security happens in the enterprise today, and that this is what you needed to start doing. This is a quote from that presentation, and it's a quote from actually Tim Bray from 2 years earlier in a talk called You're Doing It Wrong, where Tim Bray said, the community of developers whose work you see on the web, who probably don't know what ADO or UML or JPA even stand for, deploy better systems at less cost in less time, and most importantly, he said, at lower risk than we see in the enterprise. The point here is that by making these smaller changes and making them more rapidly and doing it in this really agile way and working with the operations and development teams, there was less risk inherent in the kind of work that they were doing, and this made for much better applications. That Belgian gave this talk at OWASP, a security conference in Belgium, and this is some content from some of his slides. He basically said that people, meaning developers, hate sysadmins because they slow stuff down, they say no, they care about uptime, they refuse to break stuff. And he said that people, meaning developers and sysadmins, hate security officers because of the same reasons. And then he added this other one that I think is really interesting. Security officers have an expiry date. And I think what he means there is when you get hacked, they get fired. So they're not going to be there forever. At least the operators can fix the problem, So it used to go dev and ops and security were fighting, and what he started to see was that DevOps and security were fighting. But security is vitally important, especially to the DoD. Agile and DevOps taught us that if you want these teams to work together better, you've got to get them communicating. You've got to communicate back to them. You have to respect them and their expertise and, earn their respect for your expertise. There has to be an establishment of mutual trust between these teams if they're going to work together in order to help accelerate delivery. There are developers in the Army, several kinds. I told you before that my history is in cyber operations, so of course cyber has developers. There are data science developers in like the Army AI Task Force, of course ORSAs. There are a few other organizations across the Army that have developers. There's a lot of Army civilians and contractors who do development. Some of them might be scattered in this audience, but they're really the exception and not the rule. All these things are built to evaluate risk, and humans are really bad at evaluating risk. If you look at like prospect theory or the framing effect, you begin to understand just how terrible humans are at understanding and evaluating risk well. So supposedly, the cyclical part of planning an AAR is supposed to be, you talk about like risk mitigation, the military decision-making process. We're supposed to be very risk averse and understand how to evaluate that risk and appropriately mitigate it. But the risk ends up evaluated in a vacuum, and the mitigations are often token actions. Inaction is in and of itself a risk. A low velocity is a risk. That process and procedures and checklists being so deeply rooted in the culture, it's a part of the cultural identity of the DoD. And overcoming that is not something that I think can be done in the short term. I don't think that full-blown agile anarchy can be done, and I don't think that it should be done. But I think that the manual processes can be mitigated and lowered. I think clicking in a graphical user interface, emptying locked containers to read serial numbers and putting things back, I think processes like that could have better ways of being done. And I see also a harsh reality in the fact that I think that tons of rework is done throughout the DoD. I think that every small problem is not unique, and often people want to be able to invent a solution to a problem because I think novel solutions make for better bullets on evaluations. And so a lot of things are just redone from scratch in order to always appear to be novel. I don't think 1,000 people doing something 1,000 times should be 1,000 bullet points worth of quality. I think that a single sweeping change to a large scale problem generating 1 bullet point for 1 person is problematic for the DoD and its ability to implement changes like this. DevSecOps requires team players everywhere. And if you had to ask me what I think the biggest barrier to wide-scale adoption of DevSecOps across the DoD is, it's probably this. But I think that there are some first steps that could begin the DoD down this path, and I think that there are some things that you should be able to do within spheres of influence to begin moving towards this path. I think that everything you can do to integrate vendors earlier and get development teams involved with security teams early, getting everyone plugged in together. Don't leave timelines to one group of people. Have everyone involved in how those timeline decisions are made. And if you can't build your own tests, through contract enforcement, then I think that testing needs to be done and automated in a way that is representative of the way it's going to be used. I don't think humans should decide if systems are secure, and I don't think reports tell you whether a thing is actually safe or not. Continuous reporting through metrics and not Word documents can help with your ability to measure and mitigate your risk, and importantly, to measure your progress over time. MDMP tells you to be planning for change, and I think that leans into the iterative, agile nature of DevSecOps. Building holistic systems and continuously evaluating how you're doing at them is important. If your ISSO is evaluating or assessing risk after you've put a system together, you probably already put it together wrong, and refactoring is not something that you have time for. So I think that they should be involved early in those architectural discussions in order to ensure that their concerns are being addressed when it's appropriate. I think a picture is worth 1,000 words. A dashboard is worth 1,000,000 checklists. I think that, training better is an enabling activity that enables you to, it's like working out. The more you do, the easier it gets. The easier working out gets, the easier doing new things is, doing different types of exercises with more muscle groups. You can continuously enable people to innovate with better training. And I think if your automation has a flaw and it causes a mistake, you can fix the automation and never have that problem again. Documentation with comments retained in version control, causing recording in code, gives you the ability to implement automation that's better than any human that ever was assessing that risk could have been. And the rework thing, I think the good news is that some of this rework is already starting to happen. This collaboration thing got figured out long ago with the BCT reorganization. Building communities that believe in these ideas at the large scale and thinking of new ideas and letting other people help refine them is going to get you to the point where I think that you're really going to be able to produce better results. DevSecOps is kind of like the open sourcing of development, security, and operations. I think that enabling more people to share ideas is sort of important thematically to the open source movement, and it resonates strongly. The more you understand open source, the more DevSecOps as a process seems obvious. And I'm going to leave you with a quote that says, "All of us is smarter than any of us," and it's kind of related to that effort. it's good news and bad news. You know, the more we work together and the more connected our communities are, and the more we share our ideas and inputs with each other, the better off we'll do, because all of us together have better ideas than any one of us could have alone. The bad news is that that quote is from a book from 1992 about how private sector methodology would be fixing the government. So I think we've got a bit to go. But I think that we should focus on getting to work. Within your sphere of influence, grow successful teams and do what you can to improve the situation, and let this idea of DevSecOps and agile development and iterative, operationally focused software development and delivery grow. And the more success it sees, the more other people will want to do it. So I hope you've learned something about these concepts. I hope you're interested enough to dig deeper. And I hope we can keep doing the absolute best work that we can for our nation's sake together. You can see the slide download link here. And once again, I really advocate watching that 10 deploys a day video. It's at red.ht/10-deploys. Thanks very much for your time.